You will find the background for the information contained in this video on the main Walter Russell site. I would recommend you review two videos, one on the color page. This one here is a fantastic presentation and details the work of Newton and Goethe, and you can familiarize yourself with the implications of the double slit experiment. Dr. Wolf here gives a fantastic overview of the experiment itself and the results. In Newton's famous optica obscura experiment, Newton isolated a narrow ray of white light. He passed that white light through a prism and he projected the ray onto a black background, and he obtained a white replica of the source light. He then discovered that by adjusting the angle of incidence through a prism, he was able to obtain a color spectrum whereby the red side of the spectrum and the blue side of the spectrum separated out. And in addition to that, he also discovered that by making this gap here sufficiently small, by adjusting the angle of incidence, he was able to get the red part of the spectrum to bleed across to the blue, and the blue to bleed across to the red. And that resulted in green emerging from the white light. Now this green emerges because of the interaction that we have, the original interaction that we have between how light and dark interact. And the spectrum is developed like so, and because of the interaction between the red and the blue, we get green developing at the center. Now, this was a huge discovery for Newton, but it only tells half the story. We should consider, in terms of Walter Russell's teachings, that this condition here is exactly analogous to looking towards the cathode. We are looking out into the darkness of space, and what we are observing is a focused, compressed light, a focal point. And depending on how the incident impacts on that focal point, we will find a separated color spectrum, namely the light that surrounds us in our daily lives, including the green, because the angle of incidence is sufficient to generate the green light. If you now look back towards the source, the original white light source, we are effectively looking back towards the anode, whereby we have an enormous compressed condition of white light. And inside that white light, we now have areas where the compression is not fully complete. So you can imagine the white light is compressing inwards here to try and make this black band as small as possible. But this is exactly the perspective that Johann von Goethe discovered when he applied himself to Newton's discoveries. Except in his case, what he found was there was a color inversion. The yellow was now on the inside with cyan on its opposite. And when the angle of incidence was sufficient to allow the yellow to bleed across to the cyan and the cyan light to bleed across into the yellow, we obtained green's opposite color, which was magenta. So we see magenta when we look back towards the anode condition, but in Newton's experiment we see green because we're looking at the cathode. We're looking at the vast expanse of space with a focal point of white light, a narrow focal point of white light. And from that, depending on the angle of incident, we receive Newton's colour spectrum, which is the light that surrounds us in this particular reality. But looking back towards the anode itself, this bright sun-like anode, a counterintuitive colour inversion occurs, and instead of getting green, we obtain magenta as being the opposite colour to green. And this is because the red is now flicked to the outside with yellow on the inside, and cyan on the inside, dark blue on the outside. Whereas in Newton's case, they were reversed around so that the yellow is on the outside, cyan on the outside here. The significance on this is that we have two perspectives on our surrounding reality. We obtain an impression of the world based on how light and dark interact, depending on whether we are looking at the anode condition, that's Goethe's anode condition, or depending whether we are looking at Newton's cathode condition. Why is this significant with the double slit experiment? In the double slit experiment, we know that when there's a single slit present, when particles are passed through that single slit, a single band is detected on the receiver, which is indicative that indeed particles or spherical particles have passed through this slit and are impacting at the detector in a very narrow band. When we pass a wave through that single slit, we will, over a period of time, obtain a distribution pattern at the detector, which is more indicative of wave-like character. Now, if we look closely at this arrangement here, we could say that the single slit is analogous to looking at Newton's cathode condition. If we look at this single slit in the same way that we approached the cathode condition of Newton's experiment, we can now look at the interaction between the slit and the surroundings in the same way that brought about Newton's green light. We see one version of reality. I believe the key to understanding the double slit experiment is not to get too hung up on the fact that a second slit has been added to the interface. Because what has happened is that we have effectively taken the single slit and divided it into two. We have put a bridge between the slit 1 and slit 2. Now, what we've actually done by doing that in magnification, we have generated the anode view, or the anode perspective on reality. This is Goethe's perspective, where he's looking back towards the source. This condition here is exactly the condition here. Adding a second slit is really a passive gesture. What's really important and what takes dominance in the experiment is this bridge, because now what we've done is we've inverted our perspective. We are now no longer looking at Newton's perspective. Simply by adding the double slit, we have effectively added a bridge. And that bridge gives us the double slit. but it's the interaction that the slit has with the dividing bridge that's crucial, because it inverts our perspective. Now what's happened is, rather than looking at Newton's cathode perspective, we have created an inversion where now we're looking at Goethe's perspective. He's looking back at the anode. If we look at this here in a slightly expanded view, you'll see what I mean. We are now looking at Goethe's perspective. Simply by adding the second slit, I'm arguing that that slit is secondary to the experiment. What's vitally important is by default, we have added a dividing bridge. So, rather than Newton's green colour perception, which we would obtain in the single slit, we will obtain Goethe's magenta colour. And that simply comes about because what's happened is the bridge between the two slits is the dominant characteristic of the experiment. And we have a different interaction occurring. We have an inversion, a counterintuitive inversion that we wouldn't have known about had Newton been the sole voice in the light experiment. Without Goethe's interaction, we would never have learned that a light inversion occurs and magenta appears through the interaction of cyan and yellow. If we look towards the anode, but looking towards the cathode, we obtain Newton's perspective. This concurs with Walter's interpretation that we live in a two-way universe. We perceive anodes and cathodes depending on our orientation. And we can interpret our world in terms of anode and cathode perspectives. The crucial link between Newton and van Goethe's work in the Optica Obscura leads directly into the results of the double slit experiment, but it's not the second slit that's important. It's the dividing equator and how the darkness interacts with the light, because by introducing that dividing equator, we have flipped our perspective. We have moved from Newton's cathode perspective to Goethe's anode perspective. And as a result of that, the light interactions are different.